Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. Today is 21st June 2025. This video is on a Science magazine article published on 19 June 2025. It's a review on neuroinflammation across neurological diseases. In this podcast, we're lighting a fire under an essential theme, neuroinflammation. Friend, foe, or both? Let's explore how the shared pathophysiologic thread unravels differently across multiple sclerosis, stroke, Alzheimer's, and Parkinson's, and what new therapies aim to douse the flame without snuffing out repair. What is neuroinflammation? Neuroinflammation refers to the activation of microglia and astrocytes and the infiltration of leukocytes into the CNS. Initially protective, this response often goes rogue, driving a vicious cycle of neuronal damage. And how does it differ across neurological disorders? In multiple sclerosis and stroke, there's early immune cell invasion. In Alzheimer's and Parkinson's disease, protein aggregate triggered, and there's chronic inflammation. Microglia, guardians turned arsonists. Microglia are the first responders of CNS. They clear debris and signal repair, but chronic activation leads to reactive oxygen species, cytokines, and neurodegeneration. In multiple sclerosis, the microglia are destructive from the outset. In Alzheimer's disease and in Parkinson's disease, it's biphasic, initially helpful, later toxic. Why do CNS-penetrant drugs matter? In progressive diseases where the blood-brain barrier is intact, the drugs must be CNS-penetrant. They are necessary to modulate resident immune cells like microglia and astrocytes. Multiple sclerosis, lessons from a model disease. Multiple sclerosis gives us the clearest blueprint. Disease-modifying therapies work early. Later stages need brain-penetrating agents. What are CALs? They are chronic active lesions with inflammatory rims. They are the hallmarks of microglia-driven disability in progressive multiple sclerosis. Stroke, the inflammatory cascade. Stroke-induced DAMPs or disease-associated molecular patterns activate microglia within minutes. T cells infiltrate by day 2 to 4. How is neuroinflammation triggered after stroke? DAMPs, reactive oxygen species, cytokines, and leukocytes influx drives secondary injury. Alzheimer's disease and Parkinson's disease, where cleaning crews are gone rogue. The initial microglial response in Alzheimer's disease and Parkinson's disease clear aggregates, but when phagocytosis fails, microglia propagate tau and alpha-synuclein toxicity. What supports microglia's biphasic role? Early translocator protein binding, TSPO, is associated with slower decline, and persistent activation is associated with atrophy. What's working? What are the current immunomodulatory strategies? Multiple sclerosis, there are nearly 20 disease-modifying therapies. Bruton tyrosine kinase inhibitors, BTK inhibitors for progressive forms. In strokes, there's fingolimod, Apitol, natalizumab in early trials. Biomarkers and precision immunology. Which biomarkers help to monitor neuroinflammation? TSPO PET, neurofilament light chain, cytokines, TREM2, and C1q. What novel approaches exist? CAR T-cell therapy, triggering receptor expressed in myeloid cells, or TREM2 agonists, BTK inhibitors, niacin, and hydroxychloroquine. So key takeaways: neuroinflammation is not one disease. It's many flames with different fuels. Timing and targeting matter. Whether managing stroke or progressive multiple sclerosis, understanding the immune terrain is the key. To control the fire, you must know Who lit the match? If you enjoyed this episode, share it with your colleagues. When we change how we see disease, we change how we shape lives. Until next time, stay curious, stay compassionate, and keep seeking wisdom. Podcast brought to you by Master MedFacts at mastermedfacts.com.